This video looks at similarity with area and volume. So if you haven't already done so, can you find the starter sheet and have a go at the starter questions? Pause the video and try that now. Those of you that have already had a go at the starter, we're just going to have a quick look at the solutions together. So for the smaller cubed, my surface area is going to be the area of one face, which is 9 times 6 faces, 9 times 6, which is 54 centimetres squared. And my volume is going to be 3 cubed, which is 27 centimetre cubed. For the larger cubed, surface area is 9 squared, and then there are 6 faces. So I've got 81 times by 6, 486 centimetres squared. The volume 9 cubed, 729 centimetre cubed. So to get the scale factor of the lengths, I'm going to divide the new length by the original length, 9 divided by 3, which gives me a length scale factor of 3. For the surface area, I need to divide the new surface area by the old surface area, which gives me an area scale factor of 9, and the same with the volumes, the new volume divided by the original volume, which gives me a volume scale factor of 27. What relationship do we notice between these scale factors? Well, let's have a look at that. So with a length scale factor of 3, the area scale factor is 9, which is the length scale factor squared. The volume scale factor was 27, which is the length scale factor cubed. So what we can say in general is if we have a length scale factor of k, the scale factor of the areas for that shape will be k squared, and the scale factors for volumes will be k cubed. Can we write this down in our notes books? It's very important to remember. Right, let's apply this to some questions then. So I'm told that the Russian dolls are mathematically similar, so that tells me that I'm going to be working with scale factors. And I'm given the heights of both the dolls, and I'm given the area of the smaller doll and asked to work out the surface area of the larger doll. So what I'd like you to do with these questions is to set them up in a table. So I'm going to have information for my shape A there. I'm going to have scale factor in the middle and information for shape B over here. And down the side, I'm going to start with my length and then I'm going to move on to area. So filling in the table, looking at the question, for shape A, I have a length of 1.2 centimetres and shape B 3.6 centimetres. So I can work out my scale factor by dividing new length over original, which gives me a scale factor of 3. But remember, that's the length scale factor, which is not going to be the same for the areas. So moving on to the areas, my area in shape A is 7.2, but I need to remember that my area scale factor is not 3, but it's 3 squared, which is 9. So to find my surface area of shape B, then I need to do 7.2 times 9, which gives me 64.8 centimetres squared. And that was shape A, and the bigger one was shape B. Okay, let's have a look at this slightly harder example, and it's slightly harder because we are not starting with information about lengths. You can see in this question, again, we're told our shapes are similar, but we're starting with information about areas. Again, we're going to set up a table. So On the outside of my table, I'm going to have my shape X, I'm going to have a scale factor in the middle, and I'm going to shape Y. I'm going to write down always in the same order. I've got length, area, and this question involves volume as well. So let's fill in what we are given. So we're starting this time with area. So we're given the area for shape X is 244 and for shape Y is 549. So to get the scale factor to go from X to Y, the areas, so our area scale factor is 549 divided by 244. Which gives me 9/4. So because I've started with area scale factor, I cannot jump straight to volume. I have to go back to length. So I'm going to go back now to my length, and I'm going to work out my length scale factor. So remember that the area scale factor is the length scale factor squared. So to go backwards, I need to square root my area scale factor, so I need to square root 9/4, square the top, root the top, square root the bottom, so I get a length scale factor of 3/2. I can now, from my length scale factor, go to my volume scale factor, because my volume scale factor, remember, is my length scale factor cubed. So cube the top, cube the bottom, I get a volume scale factor of 27/8. So if I'm given the volume of shape X as 260, to find the volume of shape Y, I need to times by 27/8. If I pop that in the calculator, that gives me 877.5 centimetre cubed for my final answer. So it's very important here to remember that let's just write this down because it's really very important. Let's write it down in red. Okay, always go back to the length scale factor. So we can write that back in our books. Right, we're going to have a look at one more example, but this time we're going to look at a ratio approach where we're given the scale factors as a ratio, because these seem to be more popular these days, giving scale factors as a ratio. So this time I'm still going to use a table approach, but I've got A to B, and I'm still going to have my length, area and volume down the side. So I'm given the ratio of the volumes. So let's underline that, and we're putting that down here. We're starting with the volumes this time. So I've got 27 to 125. That was my starting point. So that's my number one. So I want a scale factor for surface areas, but remember I can't go from volume to area. I have to go back to length. So 2, if I don't start with length, length always needs to be number 2. And to go from volume back to length, I need to cube root. So I'm going to get a length scale factor of 3 to 5 by cube rooting 27 and 125. Now I can work out my area scale factors by squaring the length scale factors. So I get area scale factors in a ratio of 9 to 25. So let's work out the fraction we need to multiply by from our ratio. Okay, so if we want to go from A to B and we are working in area, we're going to use the area ratio. So it means we're going to have to times by 25/9 to go from A to B. So where I've got an area in my smaller shape of 36, to work out the area in my larger shape, I need 36 times 25 over 9. We don't need a calculator for this one. Let's cross cancel. 9s into 36 go 4, so I've got 4 over 25. You might prefer to pop that over 1. I get 100 centimetres squared for my surface area of my larger shape. What I want you to do now is go to the area and volume similarity questions. You can see the question numbers for challenge, super challenge and hyper challenge. If you want to move on a bit more quickly, I want you to complete at least one question from the challenge, at least one from the super challenge, and then you can jump to the hyper challenge question 7 onwards.